Hello everyone. For this video today we are going to be looking at how to find the area of trapezoids. Now just as a reminder, a trapezoid is a quadrilateral, so it has four sides, and it has exactly one pair of parallel sides. And so we would see that these two sides on this particular trapezoid would have to be parallel. And remember, the parallel sides are called the bases of a trapezoid. The other two sides are usually called the legs of the trapezoid. So let's jump right in and take a look at the formula for area of a trapezoid. It's a little bit more complicated than some of the other ones that we've taken a look at so far. It's a little more involved than the formula for the area of a parallelogram or a rectangle, and even more than a triangle, although you might see some similarities between those things. So the formula for area of a trapezoid is 1/2 the height times base 1 plus base 2, or sometimes you'll hear it referred to as half of the height times the sum of the bases. That's where the base 1 plus base 2 comes from. So what are we talking about with all these letters? Well, if you look again over here at this trapezoid, remember we said that the parallel sides are called the bases. So one of them, since it would be a little bit confusing to just say b plus b, some people might think that means the same number twice. We label the bases as base 1 and base 2, or b1 and b2. And it doesn't matter which is which. The short one doesn't have to be b1, or the long one doesn't have to be b2 or anything like that. It's just to indicate that these are two separate things in our picture. So I'll label this one as B1 and this one as B2. So if I was given the measurement of these two bases, I would add those together as I'm calculating the area of the trapezoid. And that leaves the height. And you might want to jot this down. The height of a trapezoid is the distance between the bases. And remember, in geometry, when we're measuring the distance from two objects, we always measure along a line that's perpendicular to one of the objects. So you can see this dotted line that's right here. That is representing how far apart B1 is from B2. And so that would be the height. You might occasionally see a trapezoid. I'll see if I can sketch one over here somewhat decently. You might occasionally see a trapezoid where the height is actually going to be one of the sides of the trapezoid. So for instance, if I had a trapezoid where these two sides are parallel and this leg right here is actually perpendicular to the bases, then that could be the height, and this would be B1 and B2. Most of the time, though, with trapezoids, you're going to see height indicated as kind of a dotted line or a thinner line inside the trapezoid. Also, you might want to remember that the bases don't always have to be on the top and the bottom. We're going to take a look down here when we get down to example 1. We'll take a look at a picture where the bases are not necessarily top and bottom. So keep that in mind. The bases are the parts that are parallel. Let's do a quick example here. I know I didn't give you a space to do an example, but let's label some possible lengths on this trapezoid, and let's calculate the area of this trapezoid if I was given a few measurements for it. So let's say that B1, let's say that this was 4 units long, and let's call B2, let's say that that was 7 units long. And let's say the height was also 4. So how would the calculation of the area of this trapezoid look? Well, we would take area equals 1/2 the height, and we know the height is 4, so we'll put a 4 in that parentheses. And now we need to add the two bases together, B1 plus B2. So it'll be 4 plus 7. Now, once you have this kind of written out like this, you have a few options about how you want to do it. Some of you might like to just type all of this in your calculator, and that's fine as long as you're kind of careful and you include parentheses where you need them. You can type in 1/2 or even 0.5, parentheses 4, close parentheses, open parentheses, 4 plus 7, close parentheses. You could type it in like that and just hit your equal sign and get your answer that way. Or what I typically do is, especially if my height is an even number, I go ahead and apply that 1/2 to that height. I know that half of 4 is 2, and then I'll add the 4 plus the 11 and then get 11. So now I'm looking at 2 times 11. I kind of did two steps in one. I took half of 4 to get the 2, and I did 4 plus 7 to get the 11. And 2 times 11 is 22. Another way you could do this, I'll rewrite it over here. Half of 4 times 4 plus 7 is I could go ahead and I could say, well, I'm going to do the 4 times 11 here. I just went ahead and added the 4 plus the 7 to get to the 11. I'm going to go ahead and multiply the 4 times 11 and get 44. So now I have half of 44. And half of 44, of course, is going to be 22. So it's really up to you about how you want to do the calculations once you have the values filled in for height, base 1, and base 2. Just make sure if you're going to type it in your calculator that you get the parentheses where they need to be. And after that, it's just kind of whichever way you feel most comfortable. Okay, I'm going to go ahead and let you pause the video here and try checkpoint questions 2 and 3, and then we'll move on to example 1. Okay, so down here in example 1, we have one of the questions where we are given the area of the triangle. It tells us that the area of the triangle is 132. And it wants to know what is the value of B2 or base 2. And so like I told you before, this is an example where I have a trapezoid whose bases are not top and bottom in the diagram. So you just got to watch out for that. Now how am I going to do this problem? Well, I'm going to start by writing out my area formula for trapezoids. So area equals 1/2 height times base 1 plus base 2. And then if you notice here, there's 1, 2, 3, 4 places where I could put a measurement. I could put a measurement for the area, the height, and then either of the bases. If I have 3 of those things, I can find the 4th one. Up above, you had the 3 that are over here on this side. You had the height, the base, and the base, and you were finding the area. Now, we're going to put a number for the area, we're going to put a number for the height, and we're going to put a number for base 1, and we're going to solve the resulting equation for base 2. So let's jump in. I'm going to put a 132 for the area equals 1/2 of the height in this one is an 11. This is our height because it's being shown as the distance between base 1 and base 2. So 1/2 of 11 times base 1 is 9 and base 2 is what I don't know, so I'm going to leave that as B2. So here I have an equation. 132 equals 1/2 times 11 times the quantity 9 plus B2. I need to now solve this. And you have a few options again how you're going to do this. The problem is usually with this 1/2. This is usually what's going to give students some issues. It's 1/2 being involved in this equation. So I want to show you a couple different ways you can deal with this 1/2. The first way is to just go ahead and multiply 1/2 times 11. For this problem, it's not exactly the way I would prefer to do it because I noticed that this is an odd number, so I'm going to be dealing with a decimal, which might make it a little more complicated. But if you just follow the steps that you know from Algebra 1 how to solve an equation, this shouldn't be too bad. So let's take a look. We're going to have 132 equals 5.5, that's half of 11, times the quantity 9 plus B2. Now what I could do right here is I can go ahead and distribute the 5.5 into this quantity right here. So that'll give me 132 equals 5.5 times 9, which my calculator would tell me is 49.5, plus 5.5 times my base 2. Now I'm trying to get base 2 by itself, so I know I need to subtract 49.5 now. So 132 minus 49.5 is going to give me 82.5. So I just subtracted 49.5 from both sides to get that. So minus 49.5 on both sides gives me 82.5 equals 5.5 times B2. Now I'm going to divide both sides by 5.5. And like I said, this is just maybe a little bit annoying because you have to deal with this decimal. But if you have a calculator handy, it really shouldn't be that big of a deal. If I take 82.5 and I divide it by 5.5, I should get 15. So B2 is equal to 15 feet is my unit that I'll be using there. So that's one way I could solve this equation that results there. Let me show you another way you could do this. So I have 132 equals 1/2 of 11 times 9 plus B2. I'm just rewriting this original equation that I had right here. Now I'm going to deal with this 1/2 by multiplying both sides of my equation times 2. What's going to happen over here on the right side is if I do 2 times the 1/2, well, half of 2 is 1. And so a 1 being multiplied by something isn't really necessary. We don't have to write that. So in a sense, basically what happens here is multiplying by 2 on this side makes the 1/2 go away. But I have to do it over here too. So 2 times 132 is going to give me 264. So now I have 264 equals 11 times 9 plus b2. Now what I could do here is I could go ahead and distribute like I did over here. I could multiply the 11 times the 9 and 11 times the b2. But I'm going to show you a little shortcut. I think this is going to make this problem a little bit easier. I notice that what this is saying is 264 is 11 times this thing right here, this quantity in parentheses. What I can do at this point is I can divide both sides by 11. What that's going to do over here is it's going to cancel out the 11 on top with the 11 that's on the bottom now, and that's going to leave just 9 plus b2. 264 divided by 11 is going to give me 24. So I have 24 equals 9 plus b2. Now I recognize all I need to do is subtract 9 from both sides, and I get my answer of 15. Same answer I got right there. But I think you can kind of see it's a little bit shorter. It involves far fewer steps. It doesn't require me to deal with a decimal in there. And I think overall it's a little bit easier way of doing this. But it's your choice. You can do it either way. So right now what you're going to do is you're going to work on problems 4, 5, and 7. Notice that this is problem 7 here, not problem 6. So work on those 3 problems. Put your answer in the blanks that are going to pop up here in a second. And that'll be it for this video. So good luck.